Good evening, everyone. The recording has Today we'll be discussing your assignment for the week 5 lecture, and I guess I'll wait for 5-10 minutes before we start the class as usual. Let's wait for others to join and then we'll start this class.
Excuse me, ma'am.
Yes.
Ma'am, week 5 assignment, the deadline is already gone, ma'am. So it's if we can discuss the week 6 assignment.
No, in this lecture now, in this tutorial session, we are discussing the assignment for the previous year questions, like the assignment that was given last year. So it is some kind of your practice tutorial
Mm,
session. And if you're having any doubts in your
yes.
week 6 assignment, you can ask those doubts in this class only.
Okay, ma'am.
Okay. So, Mriganka and I guess Pragya, we'll wait just for 5 more minutes and then we'll start the discussion.
Okay, ma'am.
Okay, so I think we can start the class now and let others join when they come. There's no point waiting for beyond a certain.
Yes,
Okay. So is the screen visible?
yes, ma'am, visible.
Okay. So good evening, everyone. I'm Ria Verma, a PhD research scholar from the Department of Civil Engineering, IIT Roorkee. And today we'll be having your discussion session for assignment for the week 5 only. So let's start with the questions. I hope you all have attended the lectures for the week 5 and are clear about the concepts of the emission inventories and types of emission inventories and how to create those emission inventories. I hope you all have read those concepts. Okay, so your first question is just a second. Okay, so the first question is the IV model used for estimating emissions from vehicles stands for, and your options are option A, international vehicle emission, option B, interactive vehicle emission, option C is sorry, initial vehicle emission, and option D is idling vehicle emission. So, any idea? Anyone?
International vehicle emission.
Okay, Harsha, international vehicle emission. Let's see. And what this IV model is used for? Okay, let me explain this. Yes, your answer is correct that it is international vehicle emissions. So this IV model, it was developed jointly by the University of California and then your Global Sustainable Systems Research and International Sustainable Systems Research Center, and it was funded by US EPA. So basically, what this model does is it takes into account the various technologies and the conditions that exist in the developing countries, such as the different types of vehicle driving patterns, your the mental condition of the driver, the physical vehicle specific behavior, engine stress distributions, like type of engine, and what kind of emissions are being generated from that. So the inputs that we give to the model that include the type and age of the vehicle fleet, like what kind of vehicle fleet is there that we are considering for the emission, and what age basically the age of the vehicle also affects the um, emissions, the rate of emission. There is basically the older the vehicle, and if it is not maintained or serviced properly, then the rate of emission will be much higher as compared to the new age vehicles. And also the local conditions such as ambient temperature and pressure, as we all have studied in the previous lectures also, that the ambient conditions, for example the temperature gradient or the lapse rate, and also the pressure in the environment affects the rate of emissions, and also the like it also affects the deposition of the pollutants in the atmosphere. Next is your fuel specifications. For example, what kind of vehicle you are using. Are you going for an electric vehicle, or for example, whether it's petrol or diesel vehicle? Because every vehicle has a different kind of emission. And since we all know that electric vehicles, they generate basically they generate do not generate any kind of emissions, but that doesn't mean that they doesn't harm the environment. Because see in for the Indian scenario, for our generation of electricity, we are largely dependent on the thermal power plants and other kind of power plants. But these thermal power plants, what they do during the generation of this electricity, now they generate a lot of emissions. So in one way or the other, we are polluting the environment. Unless and until we find some of the green energy source, or some of the better sources of generation of electricity, we can't say that it is totally green. Then this model is used to estimate the criteria pollutants, the greenhouse gases, the six criteria pollutants that we have read earlier, the greenhouse gases and the toxic pollutants. So the pollutants include carbon monoxide, excuse me. So the pollutants, these include carbon monoxide, VOCs, NOx, PM2.5, PM10, CO2, N2O, methane, ammonia, benzene, lead, 1,3-butadiene, and aldehydes. Basically, these are the pollutants that are being emitted from the exhaust of the vehicles. So this is the basic equation that we use in the IVA model, and this equation can estimate the emissions from a single roadway or an entire area. Basically, the source can be a line source that is from a single roadway or an entire area for specific time periods. We have to define the time periods for that. And there are some terms that are being used in this equation, and here these are or the terms are explained here, which were which will be used in this equation. And this equation one, it estimates the adjusted emission rate by multiplying it is basically it estimates the adjusted emission rate by multiplying the base emission rates by various correction factors. Then this is the next equation that is used in your IVA model, and this also weights the adjusted emission rate by travel fraction of each technology and amount of each driving type of each technology. And the result is the overall fleet running emissions for allocated time or distance in grams. Basically, it will give the emissions in weight only, in grams. So, okay, so coming towards the next question. Second question is, which of the following type of vehicular sources is not considered while estimating non-exhaust emissions? Option 1 is your tire wear, option 2 is your brake wear, option 3 is your road dust, and fourth is your tailpipe emissions. So basically, which of these is not a kind of non-exhaust emissions?
Road dust.
Road dust. Okay, correct. The answer is road dust. But not just the answer, we should know the meaning of all these terms as well. What is your tire wear? What is your brake wear? What is your tailpipe emissions? So for that, we'll be discussing your sources of vehicular emissions in some more detail. So majorly, these are all the kind of vehicular emission sources that we can observe. So first is your resuspension of your road dust. That is the dust that is already there on the road surface when the vehicle moves. So what it does is when the movement of vehicle is there, the dust that has been settled down on the surface of the road now, what it does is when the vehicle moves there's some motion. So due to that disturbance, the road dust it gets resuspended in the environment. So that is also a source of particulate matter, the resuspension of road dust. Next is your road surface wear due to the friction between the surface of the road and your tires. That is also a source of your particulates. Then abrasion of tires, brakes, and clutch. Basically, during the movement of the vehicle, there's abrasion between your brake pads and your tires, and also your clutches that is used for the driving purpose. So these are also a source of particulate matter. So you can clearly observe that one thing that this vehicular emission include a major amount of your particulate emission. So that is why we can clearly observe that in the metro cities where the number of vehicles is quite high on the roads, there the emission of these particulate matters or the amount of particulates in the environment is also comparatively higher. Next is your evaporative emissions. These include your hydrocarbons and VOCs. Then your refueling losses during whenever the fuel is being filled into the like in the car only. Then there are also some losses, and the fuel gets evaporated basically. So that in that evaporation process, the some of the hydrocarbons and VOCs are emitted. Then your exhaust emissions. Basically, these are your tailpipe emissions that are being generated from the tailpipe of your car. And these include CO2, carbon monoxide, hydrocarbons, NOx, and particulate matters. So the basically what we have done is we have bifurcated the vehicular emissions into two parts. First is your exhaust emissions, and then are your non-exhaust emissions. So the exhaust emissions basically this one, like the emissions that are being generated from your tailpipe. So the exhaust emission is emitted from the tailpipe and as a result of incomplete combustion of fuel inside the engine chamber. So what is generally observed is the emissions from a diesel car. I guess these are comparatively more from a petrol one. And when the vehicles are older, then also the emissions are more. Then your major pollutants emitted from exhaust emissions, these include your carbon monoxide, hydrocarbons, nitrogen oxides, then your carbon dioxide, particulate matter, etc. Then your sources of vehicular emissions. So the sources of your vehicular emissions, these are evaporative emissions due to evaporation of gasoline in the vehicles as explained. And for example, VOCs, hydrocarbons, these are your evaporative emissions. And then your non-exhaust emissions are there. Basically, these are due to the friction, that abrasion that is occurring between your sorry. These include your emissions due to abrasion. Abrasion, that is friction or rubbing motion between whether it's your brake pad and your tire or your clutch or some or the other thing. So these are your sources of vehicular emissions. Non-exhaust emissions, as explained, these are the abrasion of tires, road, and brake wear, as well as resuspension of the dust, explained earlier. The dust that gets settled on the surface of the road due to the motion of those vehicles, it gets resuspended in the environment, and this further leads to an increase in the amount of particulates in the environment. So next up we have so basically, the among all the vehicular emissions, the major pollutants that we can observe are your PM10, PM2.5, and your heavy metals. These are the major amount of emissions that we can observe. Okay, so next question. Sorry. Which pollutants emission is not estimated by the gains model for industrial sector emission inventory? So in your class, you must have gone through that gains model in the industrial and emission inventory. So among these pollutants, which is not estimated by the gains model, among all these pollutants, which is not estimated. So first you have methane, then you have sulfur dioxide, then heavy metals, then your NOx, nitrogen oxides. So which is there? Any idea?
Heavy metals.
Heavy metals. Let us see what Gaines model tells us. Okay, so your Gaines model, what is this Gaines model? Basically, it stands for greenhouse gas and air pollution interactions and synergies model. So basically, this Gaines model, it grew out of the regional air pollution information and simulations model, and it was which was developed by NASA APD. And after that, this model is an integrated assessment model which deals with the costs and potentials of for air pollution control and greenhouse gas mitigations, and accessing the interactions between the policies. So basically, it revolves around those the greenhouse gases, the emission of the greenhouse gases. So definitely, heavy metals is not a part of those greenhouse gases. That's why it will not be included in that. So how this model works? Basically, this model estimates the historic emissions of major air pollutants, sulfur dioxide, NOx, VOC, particulate matters, ammonia, and greenhouse gases, that is CO2, methane, and fluorine gases. For each country, based on data from International Energy and Industrial Statistics, emission inventories, and on data supplied by countries themselves. So basically, on the basis of the data that is given by the countries, or the basis of the emissions from different industries, the Gaines model estimates the historic emissions for each country, and then the potential emission reductions that are offered by about 2000 specific emission control measures and their costs. So basically, why do we use this model? What it does? So we use this model to estimate the overall emissions. First of all, we know the emissions that have been occurred in the past. So we give those inputs to this model, and what it does is it has approximately 2000 emission control measures. So it gives us an overall idea about what kind of emission measures that we can take, emission control measures that we can take, and how much cost that will happen if we take those measures. So this is the kind of model that we have, and it can be operated in two ways. First is your scenario analysis mode, and next one is your optimization mode. So the scenario analysis mode, basically what it does, it follows the emission pathways. So from sources to the impacts, like what kind of source will generate what kind of emissions, and what will be its impacts, and then it will give you the estimate of the regional costs and the environmental benefits of the alternative emission control strategies. So, and the next is your optimization mode. So basically, the optimization mode is, as the name suggests, it will give you the most cost effective or the most optimized way of reducing the emissions. And what is the difference between these two modes is that the scenario analysis mode, basically it is more of a like source and like emission and impacts, and then it's like what how do we say it, and then it's prevention or control strategies type of method. While optimization mode is the more not that of like it's not the study of every scenario or every kind of a source and its impact. It just in general gives you uh, the pathways where the from which the emission can be reduced most in the most cost effective manner. So how Gaines model works? So basically, it reveals you three ways to reveal policy interventions with multiple benefits. First one is your simulation of the cost. Next is your cost effectiveness analysis, and third one is your cost benefit assessments. So simulation of the cost. Basically, the health and ecosystem of the benefits of user-defined packages of emission control measures. So it includes the economical, not economical. Basically, here the benefit is in terms of your health and terms of your ecosystem, and we go for those measures, those control measures where we are achieving a healthier environment and a more sustainable way to reduce the emissions. Then is your cost effectiveness analysis. Here we identify the least cost packages of measures that achieve user defined policy targets. Here We are not much concerned about your health outcomes or your ecosystem or the other environmental things. We just take that measure, which is the least cost package. And for your cost benefit assessment, these maximize the net benefits of the policy interventions, like how much benefit that we can generate from these policies. So that is your cost benefit assessments. So I guess I have, okay, I've answered this question. Now, your next question. The emissions from industries are a function of, so first is your quality of fuel, second is combustion efficiency, third is your stack emission controls, and next is all of the above. So, what kind of emissions are expected from industries, and like on what factors do that emissions depend? That is basically what is being asked in this question. Like, what are the factors that affect the emissions from the industries?
All of the above.
Okay, yes, all of the above, correct. Now, let us see how these factors affect the emissions from industries. So, basically, your industrial activities that use the combustion of fossil fuels to meet their energy demands are responsible for emissions of air pollutants and greenhouse gases. We all know that the industrial activities, for example, like in leather producing industries or some manufacturing industry or some industry where some kind of combustion is going on. So these all include the combustion of fossil fuels for meeting their energy demands. And this combustion of the fuel that is responsible for the emission of air pollutants or large number of air pollutants being emitted from these industries, and that is why it is responsible for the increase in the greenhouse gases in the environment. So your air pollution emissions from small, medium, and large scale industries, these have taken a toll on human health and the environment. Ultimately, if the number of emissions that are being generated from these industries is very huge, then definitely it is going to have an impact of your health and also the environment, because these pollutants doesn't disperse so easily. They tend to accumulate in the environment. They tend to like increase their concentration in the environment, and then ultimately we as humans have to face the consequences. So next, your industrial emissions. So manufacturing of products require energy. If any kind of industry require one or the other form of energy, whether it is some kind of combustion is included or some other source of energy is there. For example, if you are sorry, for example, in the brick manufacturing process, the during the burning process, the combustion is there, and that generates a huge amount of emissions. And these are a function of quality of fuel. How, like what quality of fuel? What is its calorific value of the fuel? If the calorific value of the fuel is high and it tends to burn properly, basically we don't have partial combustion, then the level of emissions will be comparatively lesser than your combustion efficiency. As I'm telling, that if the combustion efficiency of the fuel is higher, then what will happen is the fuel will get burnt properly. The then you will have lesser emissions. And third is your stack emission control. What are the measures that we are taking to control the emissions from the stacks? Are we using some devices or any kind of suitable measures that we are taking? This combustion efficiency thing you can clearly visualize in your homes as well. For example, if you are using a LPG gas stove, so we can observe that sometimes what happens is now the flame that is there Okay, so we can observe that the flame that is there from the burner now, when it's blue, then it shows that the complete combustion is going on, and you can see there is no residue on the bottom of your pot that you're using on that burner. But sometimes you can say that, see, when the flame is somewhat yellowish or somewhat orange or orange yellow in color, then what tends to happen is like your pot starts getting blackened from the bottom. What does this show? This shows that the combustion is not getting completed properly. It shows there's incomplete combustion, and due to that we are having that residue that is in the form of some particulate emissions that is being collected at the bottom of your pan. So this is the way you can observe your incomplete combustion thing in your homes as well. Then we have your factors affecting the industrial emissions. So what are the factors that affect the industrial emissions? First, we have the presence of a large number of sorry, I guess I was muted all the time. Okay, anyway. So, coming towards the factor affecting the industrial emissions. So, for your industrial emissions, the factors that affect it are the presence of a large number of small scale industries. Next is your use of outdated technologies. Then you have lack of policies to control pollution. Then we have unplanned industrial growth and inefficient waste disposal. So we'll take these factors one after the other. So let's say first is your unplanned industrial growth. So we have observed that the cities that are not planned properly now. So what happens is we have industries lying on one side, and you can also observe that the residential areas are also present in the close proximity of those industries. So if the industrial growth is not properly planned, what will happen is the emissions from the industries, from the stacks of those industries, what will happen? They tend to accumulate in the environment. They tend to affect the environment, and ultimately the people who are residing near and in the nearby areas, their health will start getting deteriorated because of those emissions which are being done by those industries. So this is how the industrial emissions affect the health of the human beings. Then your presence of a large number of small scale industries, because see, uh, if we say there's one large scale industry, and it is generating some amount of output, and we have like for example 5-10 small scale industries that are generating the same amount of output collectively. So as compared to both these scenarios, the emissions that are being generated from that one large scale industry will be lesser as compared to a large number of small scale industries. So that is how the number of industries you're affecting the industrial emissions. Next is your use of outdated technologies. Definitely modern technologies, or up to date technologies, they are at par with your they are better at dealing with those industrial emissions, because these days we are more concerned about the environment. So we are definitely building such technologies that are generating lesser amount of emissions. So if you are continuously using the technologies that have been outdated or that are being used in the past, so they will be creating more emissions as compared to the modern technologies. Then lack of policies to control the pollution. Certainly, there are some policies that tend to control the pollution, but how much of them are being followed, that we all don't know. And also, we don't have that much policies that we can control the industrial emissions. So definitely this needs to be this is one thing that needs to be corrected. Then major emissions, apart from those stack gas emissions, some other industrial emissions that include the inefficient waste disposal methods. Because of the during any kind of manufacturing or any kind of a process that is being done in the industry, a lot of waste is getting created, and it is very necessary to have a proper waste disposal method, either it is in the form of solid waste or some kind of liquid waste. It is very necessary. It's not like you just have your solid waste and you just dump it wherever you want, because in one way or the other it is going to pollute the environment. So it's very necessary that as properly you handle your industrial processes, you handle that waste disposal process that properly as well. It should be efficiently done, and done in such a manner that it doesn't harm the environment. So these are the factors that are affecting your industrial emissions. So next question. The major pollutant released from enteric fermentation is, so the options are methane, then your N2O, then SO2, and then
CH4,
which one?
CH4, I guess.
CH4, methane. Let's see. First of all, let's discuss the emissions from the industrial activities. I guess I have answered the above question. Yep, correct. Okay, so let's see the emissions from the agricultural activities. So, basically, what are the sources of emissions from your agricultural activities? First is your enteric fermentation. Next is your farm operation. These farm operations include your irrigation, your tillage and sowing, your pesticide production and transportation, then your fertilizer production and transportation. Also, this not only their production and transportation, also their application in the fields. That is also creating some emissions. Then your open burning of crop residue. This we have observed very well in your this Haryana region. Now, okay, so your enteric fermentation. Basically, the enteric fermentations uh, include the emissions of the your methane gas CH4, and the equation here it includes the estimation emission of CH4, that is summation of a number of animals into EFCH4, where it is emission factor, emissions of CH4 from enteric fermentation. EFCH4 is your emission factor for methane, and the J denotes the type of the animals that is there. So it will be first. Let's mark this as CH4. And this is the your N2 and NH2 emissions are calculated using the given equations. This is basically nothing much, just the number of animals multiplied by your emission factors. Then your emissions from irrigation. The emission of CO2 after irrigation is calculated as CO2 minus C irrigation in kil so that is equals to amount of irrigation water applied multiplied by 2.724, which is your energy kilowatt in kilowatt hours that is needed to lift 1000 meter cube of water from 1 meter depth without any loss in pump efficiency. I don't think that much is needed. Anyway, so next is your tillage and sowing. So this process also includes some kind of CO2 emissions, because we are also using tractors for this tillage and sowing process nowadays. Earlier, it was used to get done by hands. Now we are using vehicles, so definitely some kind of emissions will be there. Then your pesticide production and transportation, that is also generating some kind of CO2 emissions. Similar is for your fertilizer production and transportation. And next is your open burning of agricultural residues. So The primary crops considered for inventory preparation are rice, wheat, maize, sugarcane, and cotton. I guess these five crops are the major contributors towards the agricultural residues, and when they are being burnt, then a lot of emissions are being created, and this is a major reason. That is why there is during the months of October and November when uh, these agricultural residues are being burnt in this Haryana belt, the emissions are getting transported over this Delhi region. So that is why we have such high amount of pollution in winters in Delhi. Okay, so we have next question is which of the following tools is used for estimating the agricultural emissions? First is your COPERT, next is your GLMI, next is your MOVES, and then is IV.
Ma'am, option B.
GLMI, correct answer. It will be GLMI only. So there are the tools for estimating the agricultural emissions. Some of the softwares or the tools that can be used for estimate your agricultural emissions. These include the AG module of the State Inventory Tool (SIT), Agricultural Emission Estimation (AGRI) tool, then your Global Livestock Environmental Assessment Model Interactive (GLAMI), then your Agro Chain Greenhouse Gas Emissions so ACE. These are the tools that are used to estimate the agricultural emissions. Next, the general equation for calculating the emissions from the residential or commercial sector. It is the product of first fuel consumption and emission factor, next is your population and emission factor, next is your fuel consumption factor and duration, then your fuel consumption and
Option
population.
A.
Fuel consumption and emission
Option
factor.
A.
Okay, yeah, fuel consumption and emission factor. I guess this will be right. Let's see. So, what kind of pollutants that are being emitted from your residential and commercial sectors? Let's have a look into that. And also, how these pollutants are being generated, what are their sources? We may also have a look into that also. So, the pollutants that are associated with your fuel combustion in the residential and commercial sectors, they include your particulate matters, black carbon, organic carbon, sulfur dioxide, carbon dioxide, oxides of nitrogen, your carbon monoxide, methane, non-methane volatile organic compounds, NMVOCs. So these are all the pollutants that are associated with your fuel combustion. So the emissions from residential and commercial sectors in India. So according to a policy brief by CCPAC, the for household air pollution, uh, basically what they have told is that the household air pollution, that is the name that has been given to your residential and commercial emission, that this is also known as household air pollution. It contributes to almost 22 to 52% of all the ambient PM 2.5 exposure. That is like a major amount of PM 2.5 emission, or we can say the majority of total PM 2.5 emissions in the ambient air, a majority of them is being created by these household air pollutions because transportation it is, I guess, for 5% approximately. Power plants we can say 10 to 12%, industries also approximately 10%. So a major contributor is your household air pollution. So the emissions from your residential and commercial sector in India. In 2016, greenhouse gas emissions were estimated for the subcategory other sectors, which includes your emissions from fossil fuels burnt in commercial and industrial buildings. homes and activities related to agriculture, forestry, fisheries, and the fishing industry. So these are the emissions that were being calculated. And you can see that the 10.03% of the total emissions were being generated from these sectors. So if we say like this distribution of this other sectors category, 60% was from residential sector, 30%, 32% approximately was from your commercial sector, and then uh, 8% emissions were from these biomass that is being burnt for energy needs. So the basic equation for estimating the residential emissions can be uh, explained as EMIJ, emission of pollutant I from fuel type J, that is equals to consumption of the fuel type, and that is multiplied your emission factor. This is your basic equation for generating any type of emission. This is your basic procedure for estimating residential emissions. So first is you're calculating the fuel consumption rate. So how do we calculate this fuel consumption rate for each type of fuel in a specific country? So So firstly, we obtain the details of what kind of fuel is like for a specific region or a specific country, or for any particular area. We to calculate the fuel consumption rate, basically we obtain the fuel consumption rate for each type of fuel in a specific region, and then to calculate the emissions, we need to convert it into the mass unit. We get these fuel consumption rates now in terms of energy units, like here it is joules per year. Then we need to
Hello,
convert
ma'am.
it
Your
into.
voice is not audible, ma'am.
Okay, is it the same case with everyone? Anyone else can confirm that my voice is not audible? Because from my
It's
side,
audible for me.
okay. I guess please check your internet connection, because from my side everything is fine. My mic is working properly and also my internet is working properly. Okay, I'll try to speak a bit louder if there's the problem. So we need to convert this into the mass unit, that is kilotons per year, by using their okay. So we need to multiply these and use the net calorific values to convert it into mass units, and then we have the emission factor for each type of fuel. So we can calculate the emissions by just multiplying the consumption rate, this consumption rate with the emission factors, and after that we can have the temporal and spatial distribution. By this temporal and spatial distribution, we can explain it as the distribution with respect to space and time, like how the emissions are varying at different spaces, and also for a same particular space, how the emissions are varying with time. So that is your temporal and spatial distribution. Same is the case for your commercial emissions. The equation is the same: emission of pollutant from fuel type J and subsector K, then your fuel consumption for fuel type, and then your emission factor. Rest is the same. So I think we should go towards the next question if this is clear. So emissions from dash represent fuel consumption activities in the households, including domestic cooking and use of fireplaces.
Ma'am,
First is
residential sector.
yeah, it will be residential sector only. Okay, is there anyone who can explain what kind of emissions we can expect from all these four sectors, your agricultural sector, industrial sector, then residential, and then transport? See, we have discussed so much till now, so I guess at least a slight bit of idea, like what kind of sources are we expecting from all these sectors? What are the major sources of the pollutants from all these sectors? Like from your agricultural sector, what is the major source of pollutant? Your industrial sector, what can be the major source of pollutant? Then your residential and transport. Let's have a healthy discussion. Anyone who wants to answer? No one? Okay, so I guess okay, let's discuss this. So, for example, if you consider your agricultural sector, so you start seeing this sector, you just start visualizing what kind of emissions can be generated from this sector. For example, during your activities, what kind of activities that are included in that sector? So, for example, during the production and transport of your pesticides and fertilizers, some kind of emissions will be there. During your sowing and harvesting process, if we are using any mechanical equipments, then maybe some emissions will be there from present from there. Then after your harvesting, if the residues that are being generated, that they are being burnt, then some kind of emissions definitely will be there. And apart from that, if we are applying some kind of pesticides or fertilizers to the field, and during the irrigation, if like evaporation is happening, the evaporation is continuously happening in the field. So what happens is the pesticides and fertilizers that we have applied in the field now, they tend to evaporate, and they then these harmful chemicals get into the atmosphere in the form of harmful gases. So that is also one source of pollution. So we can clearly tell the sources of pollution just by knowing the activities that are being involved in any kind of sectors. For example, let's take into account the residential sector. So basically, what this sector does is, in the residential sector we have your fuel combustion activities in households, including your domestic cooking, and also the use of fireplaces in the houses which are in the colder regions. We have fireplaces to keep the houses warm. So some emissions are from that area also. And your household stoves, although they are very small, but they are, if we club together all the stoves, they are numerous and thus have the potential to contribute to decreasing the air quality by increasing the emissions. So this is your emissions from your residential sector. Then we have your this question. The remote sensing technique uses dash to measure vehicular exhaust emissions. So what does the remote sensing technique uses to measure your vehicular exhaust emission? First is your absorption spectroscopy. Next is your gravimetric technique. Next is your UV aerosol index.
Option C.
Option C, UV aerosol index. Okay, let us see. What is this remote sensing technique in air quality management? And what are its application? So in the air quality management, the remote sensing technique is used for these is used for these purposes. Basically, it can be used for your air quality forecast, then your improved characterization of surface level air pollution, then your improvement of emission inventories and incidental releases, then the monitoring of air pollution data, then your validation of models. The remote sensing techniques can also be used in the formation of your emission inventories, or then your identification of air sheds, then demonstration of episodic pollution, and also inspection of consistently non-compliant sources. So these are the purposes for which we can use the remote sensing technologies in the air quality management. So, for example, one of the application is in the transport emission inventory. So, the remote sensing data can determine the emission rates for whole fleets. For what is a fleet? Fleet is a basically n number of vehicles moving in a single line. So that is a fleet. So for the whole fleet, the remote sensing data can determine the emission rates for specific vehicle types and for vehicle classes by emission standards. And if sufficient data is available, then it can also be for used for distinct vehicle mix and models. So this technique measures, basically remote sensing technique measures exhaust emissions by absorption spectroscopy, and without interference with the vehicle, its driver or the driving modes. So how are we using this technique in the transport emission inventory? So how the exhaust emissions are measured. So basically the sources of infrared and ultraviolet IR and UV lights are placed next to the road with their beams directed across the road at the height of the vehicle tailpipe or the exhaust plume. So you can clearly see these are the speed bars, and these here, this one, small, these devices, these are the UV and infrared sources, and here we have the spectrometer. So the these speed bars are used to measure the speed of the vehicle, and this UV and infrared source, what it does, it has a beam that is directed towards the tailpipe of the vehicle, and as soon as the vehicle moves from this side, the speed of the vehicle and then your what do we say, the exhaust emissions, these are measured from these sources. The measured attenuation reduction of the light is directly proportional to the concentration of the certain pollutants. What will happen is we have a beam of light that is present, that is being generated from these UV infrared sources. Then whenever a vehicle moves from this path, due to this emission from its tailpipe, there is a reduction of light, and the amount of reduction of that light, that is proportional to the concentration of pollutants which are present in the atmosphere, and definitely these pollutants are being obtained from those tailpipe emissions. So these can come from the exhaust of the vehicle that is just passed, as well as from the background presence of the species in the ambient air. Also, it is a possibility that there is some emissions are present in the background of the vehicle. Then, therefore, the pollutant concentration was measured before the vehicle crossed the light beam as taken as background pollution, and then subtracted from the measurement. So, for the your accuracy purposes, what we do is we subtract the pollutant concentration that was measured before the when the vehicle has crossed, and then we have the your pollutant concentration after the vehicle has crossed, and and when we subtract both of them, then we get the emissions from the total amount of emission that is being generated from the vehicle. Next is application of remote sensing in your transport emission inventory. So basically it was this instrument configuration, like this speed detector and your source and detector module. Then you have video camera and license plate reader. So this configuration was developed in 1989. Then this includes the following units. The first unit measures the vehicle emission by absorption spectroscopy. Then you have second unit which measures the speed and acceleration of the vehicle at upstream of the emission measurement. And the third unit, a camera that is records the number of the vehicle. And then we have a new remote sensing instrument that is your ADAR, and it was developed by Hager Environmental and Atmospheric Technologies (HEAT), and it uses laser at a light source, where earlier we used to have your IR and UV methods, spectroscopy. Here it is using laser as the source of light, and thus it makes the measurement more selective and precise to the pollutants. Next, here the light source and the detector are mounted above the road in this configuration. Earlier, the light source and the instruments are present on the surface of the road at the like level of your tailpipe of the vehicle. Here, these monitors are placed above the road, and then here the laser light is scattered back from the reflector strip installed on the road surface. What we do is we have our reflector strip on the installed on the road. When the laser light gets incident on it, it gets reflected back, and this laser beam sweeps the whole breadth of the road, and then thus the exhaust plume is captured in its entirety, and the molecules in the plume can be measured. So the pollutants measured using remote sensing techniques in the transport emission inventory. These include your non-dis CO, CO2, and hydrocarbons. Then your nitrogen oxides, nitrogen dioxides, SO2, and ammonia. And the limitation of this process is that basically it works most accurately under slight acceleration. Therefore, emissions using ideal and deceleration are not captured. Basically, when the vehicle is moving with a like in a slight speed, then it is able to capture the pollutants. And when the vehicle is in ideal situation, then it's difficult to capture the pollutants. Then also the measurements are more difficult to make when it is raining condition, or the surface is wet, because then there will be no proper reflection of the light rays, and all it may hinder the reflection processes. Then your vehicle technical data are taken from the registration database. So and they record the feature of the vehicle when it is new. So the actual state of the vehicle when the remote sensing is being done, that is not clear. So that is also one sort of limitation of the this remote sensing method. Now, next question is the commonly used satellite data AOD for monitoring and estimating particulate matter emissions is, what is this term called? AOD, that is aerosol optical dispersion, aerosol optical depth, aerosol optical diffusion, and aerosol optical detection. What it will be? Anyone?
Option B, aerosol optical depth.
Yes, it will be aerosol optical depth. Any idea what's aerosol optical depth?
This only I don't have idea. Just can you explain a bit? Because this when I was doing the MCQ, so the information was also not much like adequate to explain the whole thing. So, ma'am, can you please explain?
Okay, sure, sure. I was about to explain this concept. So I guess I have added this topic. Yes, I have added this topic. Okay. So basically, this remote sensing method, it can be used to estimate the particulate matter emissions in the environment as well. So this is the name of the instrument that is being used for aerosol measurement, and it gives your data including your aerosol optical depth, product reflecting fine particle loading. I guess that is not much of mm, importance. So basically, aerosol optical depth. What happens is now, for example, see, if we have a surface here, I think it's clear to everyone now. You can visualize this.
Yes, ma'am.
Yes, ma'am.
Okay. So for example, if we have a surface here, and there are some particles that are present in the ambient air. So this light that is getting incident now, this is like the light that is getting incident on this surface. So during this process, these particles now that are present in the atmosphere, these are your particulate matter. What happens is these tend to either absorb some of the light, if like for example, if we these particles. So what they will do now, they will either absorb some of the light rays into themselves, and other way is that they will scatter the light rays, as you can see in this one. The light is getting scattered. So due to this, what will happen is the amount of light that started to travel from this point and the amount of light that is received at this end will be different, right? Getting my point? Anyone?
Yes, ma'am. Ma'am, can you repeat once?
Okay. So what will happen is, see, the amount of light here, some amount of light is getting incident from it started to travel from this point. For example, we say the sun is the source of light. So sun say there will be some amount of light that started to travel towards this surface. But meanwhile, what happened? We had some particles in its path. So what they did, they either absorbed some of the light or they scattered some of the light. Like the light that was traveling straight towards this, might be possible some is scattered here, some scattered here. Due to the presence of these particles, some scattered here, and some light may be absorbed here as well. So the light that started to travel from this point and the light that has been received at this end will be different, the amount of light, due to this absorption and scattering
Yes, ma'am.
process. Okay, so the difference, basically the difference that of between the initial and the final point, basically the reduction in the quantity of light due to this absorption and scattering. This is known as your aerosol optical depth. Got my point?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So basically, what this is now, this your aerosol optical depth is proportional to your number of particles, because the more the number of particles, the more is the loss of light due to this absorption and scattering. जितने ज्यादा पार्टिकल्स हमारे एटमॉस्फेयर में प्रेजेंट है, उतनी ही ज्यादा एब्जॉर्प्शन और स्कैटरिंग होगी, तो उतना ही ज्यादा रिडक्शन इन द अमाउंट
Yes,
ऑफ
ma'am.
लाइट होगा. सो
Yes.
That is why this term, this aerosol optical depth, is used as an indicator of your particulate matter in the atmosphere. Correct?
Yes, ma'am. Yes.
So, understood this term, your aerosol optical depth?
Ma'am.
Okay. So, basically, that is why we are using this term, your AOD, for measuring of PM 2.5 levels. So AOD column integrated value, top of the atmosphere to the surface, optical measurement of aerosol loading, unitless, and this AOD is a function of your shape, size, and type and number concentration of aerosol, as explained. Because your shape, size, type, and number concentration of aerosols, it will affect the absorption scattering, and thus AOD will be a function of these parameters. So how it is the concentration of particulate matter is related to your AOD. Here it is your concentration of particulate matter and here it is your AOD. So we have 4 rho RE. RE is your effective radius of the particulates and rho is your particle density divided by 3Q. Q is your extinction coefficient. So rho and Q, these are your composition of the particles. Then it is multiplied by FPBL, that is your percentage AOD in PBL, and then your HPBL, that is your mixing height, that is multiplied by AOD. So it will be giving your concentration of PM 2.5. So this is some, for example, an example of your application of remote sensing in like Florida and southeastern United States. We have see you can see clearly these light rays, and here it is this AOD is overlaid on a cloud image in which the lower values of particulate matters are in blue color and higher values that show high concentrations, these are in your orange and red colors. And these vertical bars, these include the PM 2.5 air quality by EPA category. These green, yellow, and different kind of bars that are given here. So I guess we are done with the questions for week 5. And if you are having any doubts, then you may ask.
Like week 6, some questions actually I have written down.
Sure, can you please share those questions
Yeah,
in
yeah,
which you have?
yeah, sure, ma'am, sure.
Okay, I think I'll stop sharing my screen. Then maybe you can share your questions. I think anyone else who's having a laptop can share the like questions for week 6 because I guess he's using his mobile phone, so it will be difficult maybe to share the questions.
Ma'am, is it visible now?
Yeah, it's visible clearly.
So these are the questions, ma'am. Actually, so like, ma'am, can you like, if you want, ma'am, I have done some few, but if you want, ma'am, can you discuss the like all the questions so that I can check the other answers also, if like
Sure,
possible?
we have time, I guess. We have our class till 8, so we can do that. No
Yes, ma'am.
issues.
So these are the questions, ma'am. Actually,
Okay. So first we have, which of the following data are associated with secondary data? Okay, so we have
yes,
basically
ma'am.
two types of data. First is your primary data, and second is your secondary data. So the difference is the primary data is your first-hand information that we collect on our own, and the secondary data is
Yes,
your
ma'am.
derived data that is basically based on your results that are obtained in your primary data. So, for example,
Yes,
your
ma'am.
questionnaires, they will be your primary data. Then your continuous monitoring, that will be also primary. Field surveys also primary. I guess published reports and articles, these will be your secondary data.
Mm.
Or question number two, dash is the practice of deriving information about. Can you please rotate your phone now? I guess then it will be more
Yes, ma'am.
enlarged. Yeah, now it's better. Okay, so dash is the practice of deriving information about pollution sources and the amount they contribute to ambient pollution levels. So, this question basically most of the students will be having doubt among option first and second, source apportionment and your emission
I think it's
inventory,
the
right?
now option one.
Yeah, it will be
Option
option
one, I
one
got.
only because emission inventory basically it focuses upon the total emissions that we are getting, and your source apportionment process it takes into account the different types of pollution sources and the amount they contribute towards the level ambient pollution levels. So it will be source apportionment only. The next questions, which of the following models follows the source based methods? Okay, I guess we have
I guess
your
option one.
Gaussian plume model, positive mass factorization model, chemical mass balance model, and principal. I don't think it will be option one. Source-based methods, right? I guess we have it in your source apportionment now. Source, we have two types of methods. First one are source-based and second are receptor-based. Um, just let me check once in my notes because I'm not sure. Just wait a few seconds. Let me see. It will be Gaussian plume model only, source-based method. The fundamental principle of receptor modeling is first is your energy conservation, next is your normal
I got option
distribution.
C.
Yeah, mass conservation, correct. Receptor modeling का basic principle is mass conservation. Correct.
I have thought in number five. Next question.
Okay, the minimum number of samples n is the one that produces a degree of freedom d to a variable v ratio. Yeah, I have read this. Just a second. This is your assignment for week 6, right?
Yes, ma'am.
Lecture. Uh, your week 6 was up till which lecture?
Sorry, ma'am.
In week 6, we have covered lectures up to, I guess, lecture 36, right?
I guess so, ma'am. Last class, due to network problem, I could not like join the this one
Oh,
lecture. So
okay. No issues. I guess then this will be from your lecture 32 only, assessment of exposure. Yeah, sampling design. I have a doubt. Shaker, when is the deadline to submit this assignment?
that's tomorrow, ma'am.
Okay, you are having your deadline tomorrow now. See, just give me some time. I think I'm having a doubt on this
Yes,
question
ma'am.
only.
Yes, yes, ma'am. Yes.
I can share the answer in the chat box by to, I think after the
Yeah,
class only. Is that
Yes,
fine?
ma'am. Yeah, you can resume. Yes, ma'am. Yes, ma'am. It's okay, ma'am.
Okay, okay. I'll just text in the chat box only the answer for this question. Let me just quickly take a screenshot of this question. Just okay. I'll just save this one.
We do you want like to take the screenshot of other questions also like six? There are
Uh,
four more six.
See, I've taken a screenshot of this question only. Let's see how many questions that we can solve together now. Just move forward to other question. Question number six.
Six I got as A.
That do not follow the distribution of data with similar characteristics. Correct. It will be your outliers.
And
Next
number
is
seven I got as D.
which of the following is not the cause of indoor air pollution? Air tightness, yes, it is. Indoor sources, it is. Yes, it is well designed air conditioning because the poorly designed air conditioning systems are a source of pollution. So it will be D. True.
I mean, next is question number eight. This nine, eight, nine, and 10. I have like doubt. Okay.
Okay. 8. Dash is defined by the depiction of concentration of pollutants and thermal conditions that may negatively affect the health, comfort, and performance of a building's occupants. Okay, it will be your sick building syndrome. Eighth is your option B, sick building syndrome. Ninth, dash is a mixture of smoke given off by burning tobacco products such as cigarettes, cigars, pipes, and the smoke
I
exhaled
I think
by.
it's secondhand.
Yes, it is
It is
secondhand smoke.
secondhand smoke.
Yes, yes, it is
Sure.
secondhand smoke. Then,
Is this disinfectants?
c- can you please repeat what you said?
Ma'am, this one disinfectants. Question number 10.
Okay, which of the following is the source of dust mites? Dust mites source? No, not disinfectants. It will be your carpets.
Okay. Thank you, ma'am. So, ma'am, it's okay. You can share the question number five, on the chat box only.
Yeah, I'll share the question number 5 in the chat box. And rest, I guess you got all your doubts.
Yes, ma'am.
Even
Yes, ma'am.
I think we can have this session every week if you want to discuss your assignment for the current week now, because since we see we have a lot of time in our class. We have a class of 2 hours, and the assignment that I discuss is of the past year assignment. So I think we
Yes, ma'am.
have type of approximately 45 minutes to 1 hour every day that we just spend by doing nothing. So I think every week we can have this kind of discussion. You can share your assignments for the
Yes.
current year question, and we
Yes,
can
ma'am.
solve
Yes,
it
ma'am.
together.
We can
And
do. Yes.
also, if you are having like any kind of doubt in any numerical or any concept that you want to repeat, we can take that also.
Ma'am, like if you and just if you don't mind, can I say something, ma'am?
Sure, sure, no issue. Even I
Ma'am,
want you guys to say that. Yeah, sure.
some doubt regarding I have week two. That is the adiabatic essay. I'm studying now the week two part. So there are some things like
Okay, okay,
adiabatic, left, right, then earlier. So those graphs and all, I have a bit problem actually.
okay. I can take that. See, we have half an hour left. So quickly, I guess I'll just go through the concepts, basic ideas about
Yes,
those
yes,
lapse
ma'am.
rates and let's see how much we can cover in today's class. So let me just share my screen. Your week two lectures. I have it. Let's start from lapse rates. Then we'll move forward towards the type of plumes. Is that fine?
Yes, ma'am. The screen is not visible.
Yeah, yeah. I'm just sharing the screen. Just wait for some time. Okay. Now is it visible?
Yeah, yes, ma'am. It's visible now.
Okay. So first of all, you want me to start with this like atmospheric stability only?
Yes, ma'am. Yes, yes.
Okay, ठीक है. So first of all, let's define stability. So, for example, if you see this place, na, this ball here, this red ball. So, for example, let's assume you just tend to like trip this ball. You just have apply a slight force on this ball. What will happen is this will either move downwards in this direction, in the right, towards the right, or towards the left. So it is extremely unstable. Clear? Next, if
Yes,
you
ma'am.
see this blue ball, what will happen is whatever force you apply towards the left or towards the right, what will happen is ultimately it will gain its original position. It will come back to it towards this end. So it is extremely stable. Then you have this green ball. So what will happen if you apply a little pressure on this one, na? Apply a little force. So for example, if you're applying pressure from the left side, it will tend to move towards the right.
Yes, ma'am.
The amount of pressure you apply and the amount of movement is there. So it is neutral. So this is the basic concept of stability. What is unstable, what is stable, and what is neutral. Now let us say, if we consider in terms of your air parcel and the ambient air temperature. So just remember this concept. कि as long as your, for example, if we consider a hot parcel of air, like for example, a parcel of a plume that is being generated from a stack, this is the parcel of air. So as long as this parcel of air is warmer, the temperature of this parcel is more than your ambient air. Is it clear?
Ma'am, what is basically ambient air and
Ambient air basically in general, you are sitting here, you are sitting in your room, the air that is present in general, the air that you are breathing, that is your ambient air.
yes, ma'am.
Ambient air is any kind of like in the for example outside environment. Just see abhi main jis environment mein I'm in a closed room, so this is my indoor air. Ambient air refers to the air in open environment, like whenever like the moment you step outside your room or outside your house, the air that is present, that is ambient air. Got that?
Yes, ma'am. Yes.
Ambient air.
Hmm.
So okay, so coming towards your our parcel. So as long as your the temperature of that parcel is more than your temperature of the ambient air, मतलब कि आपका air parcel है, it is warmer, it is hot, or it is like its temperature is more as compared to your ambient air. इसका temperature ज़्यादा है, इसका temperature कम है. It is warmer, it is colder. So what will happen is this parcel of air will tend to rise. It will rise and it will then expand. So this process is for your unstable condition. Getting?
Hmm. Hmm. Yes, ma'am.
The moment you are having any doubt, na, please feel free to ask at that point only, because there is no point कि मैं पूरा explain करूँ and then we'll repeat the same process. The moment you feel anything कि ठीक है नहीं समझ आ रहा, you can ask at that point only. Okay? So just a second, excuse me. Okay. So got the point of instability. Unstable
Yes,
is
ma'am. It's
when
like
the
when expansion due to
yeah. Tell me what is how do we say that the environment is unstable? How will you explain?
like when the temperature like with the increase in temperature, the expansion of the like air. it expands, so that's basically known as unstable.
Okay. And what is the relation between the temperature of parcel and the temperature of air in the unstable environment?
And with
Like,
temperature, I think temperature is greater than air, like the temperature of air process or something like that.
yeah, temperature of the parcel is more than the temperature of the air. So this is your unstable condition. So stable will be just opposite of your unstable. So here what will happen is your air
Yes,
parcel that is cooler than the surrounding.
mm,
Getting, for example,
yes,
if we are staying in some very cold regions, when the temperature of the ambient air is like in minus like -2 degrees, or for example 10 degrees, 15 degrees, the temperature of the ambient air is such, and the air parcel that is being emitted from the stack, it will be warmer, correct? So in
yes, ma'am.
such cases, what will happen is the temperature of the parcel will be less than the temperature of the ambient air, and that is why it will tend to, instead of going above, it will tend to sink down. And if then when
Mhm.
it sinks, it compresses. This is your stability
Mhm.
condition.
Yes, ma'am. Yes,
And the neutral condition is when the temperature of the parcel and your temperature of the air is same.
equal to
Huh. So
equal.
then there will
Yes,
be no change. So got what is unstable, what is stable and neutral. Got that?
yes, yes, ma'am. Yes, ma'am.
Okay. So let's go move further. Like for example, your unstable condition. For example, is the screen visible, right?
Visible.
Okay. So here your air parcel is at what? 15 degrees centigrade, and this 10 degrees centigrade. This is your temperature of the ambient air, correct?
Mm.
So what will happen in this condition? Without just reading that, just explain from these two temperatures, what can you say about the atmospheric condition?
Ma'am, because the 50 that inside the temperatures like temperature of the air pressure is more than the ambient air temperature. So there is like no chance of expansion.
Yeah.
Uh, there's no chance of expansion. So this will be also a case of unstable like a atmospheric condition.
Yeah, there just one correction is there. There is chance of expansion. Basically, when unstable condition is there, na, this air parcel tends to rise and expand. Contraction happens
Mm.
when the stable condition is there, right?
Yes, ma'am.
So you got this, right?
Yes, ma'am.
Now, okay. So coming towards next condition, when the your temperature of air parcel is less than the temperature of ambient air, then what will happen?
Then like then. There is basically that will remain as the position will be as it was earlier. There will be no any expansion or like compression.
Yeah, no. Is condition what is happening now? The temperature of parcel is less, so it is cooler than the ambient air, right?
Yes, ma'am.
So when it is cooler, what will happen? It will sink and compress,
Shrink. Yes, ma'am.
correct?
Yes, ma'am.
When unstable, it will rise and expand. When stable, it will
Mm,
sink and compress,
mm,
correct?
Yes, ma'am. Yes,
And when it is the same, then there is no change.
yes.
Tick. Up to this point, you are understanding your atmospheric stability condition, like what is unstable, what
बिल्कुल
is
मैम.
stable, and what is neutral, right? Okay, let's move further. Like how do you determine the atmospheric stability condition, correct? So your atmospheric stability, basically we have abhi tak we had two terms, your ALR and your ELR, like adiabatic lapse rate and then your environmental lapse rate, correct? So what this
Yes, ma'am.
adiabatic lapse rate is? First of all, let's get into very basic thing. What is a lapse rate? You know what's a lapse rate?
Ma'am, no idea.
Okay, okay, no issue, no issue. See, uh, we understand this thing. Let's break this into two parts. Lapse rate. First one is your lapse. Second is your rate. Lapse is what? The word describes in itself. Lapse is reduction in something, right?
Hmm. Yes, ma'am.
Correct.
Yes, ma'am.
Lapse is your reduction, and rate is the rate with which it is getting reduced. It
It
will be
reduces.
respect to
Yes,
something.
ma'am. Yes, ma'am.
So here, what we are using this term with reference to our temperature profile and the height. Correct. We are just discussing about these two terms, na? These altitude and temperature, right?
Yes, ma'am. Yes.
So this lapse rate will be what? It will be in with reference to these altitude and temperature. So we all know this for a fact that in general, as we move upwards, like from the surface of the earth,
Temperature
as we
decrease.
move upwards, yes, correct. The temperature tends to decrease. This is what? This is your environmental
Decrease.
lapse rate, ELR,
Mhm.
the rate
Yes, ma'am.
with which the temperature in the ambient air, like in the ambient environment, or how do we say that? In the outside world, in the outside environment, the rate with which the temperature decreases with the increase in height, that is your ELR,
Yes, ma'am.
right? Now,
Yes, ma'am.
what is ALR? What is adiabatic lapse rate? It is nothing. अभी हम क्या बात कर रहे थे? We were talking about the ambient environment. Now we are coming back to our air parcel, that parcel of air
जी, ma'am.
that we were talking about. So as soon as it moves upwards, its का भी temperature कम होगा. The temperature of the parcel will also decrease.
Yes, ma'am.
So just one correction here, what just one assumption we made that कि इसका जो भी temperature decrease हो रहा है, the reduction in the heat ना, the reduction in the temperature, ये adiabatically होगा. What adiabatically means? There is no exchange with the ambient environment. मतलब
मतलब बाहर का मैम जो एनवायरनमेंट होगा उसके साथ मतलब कोई इस एयर
कोई
पार्सल का कोई
इंटरेक्शन
लिंक
नहीं
नहीं, मैम.
होगा. एग्जैक्टली exactly. अगर ऐसा नहीं है कि अगर इसका टेम्परेचर कम हो रहा है तो इसकी हीट जो है वो एम्बियंट में चली जा रही है कि एम्बियंट का राइज होने लगेगा, ऐसा नहीं हो रहा है. सो दैट इज व्हाई वी अज्यूम दिस प्रोसेस एज एडियाबैटिक. तो दिस इज योर एडियाबैटिक लैप्स रेट. यहाँ तक हो गया.
यस.
ELR हो गया,
यस,
ALR
मैम.
हो गया. Now this ALR is bifurcated into two parts, dry and wet or saturated. तो अभी ड्राई और वेट को हम कैसे डिफाइन करें? ELR तो हो गया, उसको वन साइड करा. अब हम आ गए अपने एयर पार्सल पे. तो एयर पार्सल में क्या दो कंडीशन हो सकती है? फॉर एग्जाम्पल, या तो ये एयर पार्सल जो होगा एकदम सैचुरेटेड होगा, एज इन द फॉर्म ऑफ क्लाउड्स, गेटिंग, कि
यस, मैम.
मतलब वो
यस.
पूरा वेट होगा. तो उस कंडीशन में जब ये सैचुरेटेड है, इसमें वॉइड्स जो है पूरा वाटर से फिल्ड है, और जब तभी इसका जो भी लैप्स रेट हो रहा है, जो भी अमाउंट ऑफ रिडक्शन इन टेम्परेचर हो रहा है, उसको हम कहते हैं सैचुरेटेड एडियाबैटिक लैप्स रेट. और उसके
यस, मैम.
अलावा जो भी कंडीशन है, व्हेन इट इज ड्राई और इट इज पार्शियली सैचुरेटेड, देन वी टर्म दैट एज ड्राई एडियाबैटिक लैप्स रेट.
जी, मैम.
So terms, you're clear with the terms, right? What is ELR? What
Means
is
like
AL?
if there is like if there is मतलब like some water content or like humidity content, then it will be like ma'am ऐसे adiabatic wet adiabatic left side saturated, right, ma'am?
When it is, see, when they are telling you about like the humidity is 100%, then you can say it is
Yes, ma'am.
saturated. If it is less than 100%, even at 99 ना, you can't say it is saturated. Saturated means कि humidity
Yes,
का
ma'am.
percentage 100 हो गया. Other than that, everything is dry.
Hmm. Hmm.
Correct?
Yes.
So
Yes, ma'am.
you're clear with the terms. Okay? Now we know for a fact that the value of your dry adiabatic lapse rate and like saturated adiabatic lapse rate, these are fixed, right?
Hmm.
We have 9.8 degrees centigrade per kilometers and we have 6 degrees centigrade per kilometers. We know these values, right?
Yes, ma'am.
Okay. So the measured ELR, the value of your environmental lapse rate that we are getting, we can compare these values with both DALR and SALR to determine the atmospheric stability conditions.
Hmm.
So, Shikhar, you want me to continue today only with these comparison or different stability conditions, or
Uh,
you want me to take it
yeah,
to the
ma'am,
next
you can
class?
know, ma'am. Ma'am, you can take it in our next class. So today, like I have to, let me get clear with the terms, studying and all.
Exactly,
So next class,
exactly.
ma'am, you
And
can.
also, like I'm getting that tomorrow is Holi also, so everyone must be waiting to just end the
No,
class
not
now.
like that. No, 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 no. No, there is
Like
none.
now
There is no such
I'm
kind of
getting
thing.
because you still got so much to like gather today only. So let's do this in the next. I hope I see you all in the next class because like every class the students are different. So I don't know what will happen in the next class only. So
हाँ ma'am, ma'am, this is the perfect time actually. It's like today, no, not actually 6, 7 is the actually perfect time because when there is college, so it becomes difficult. थोड़ा दिक्कत होता है मैम जब कॉलेज होता है
yeah,
तो
I can
छः
understand.
25 को
Yeah, so we can do one thing, ki mutually we can agree to like extend this class, like because officially I've been told to take this class from 6 to 8. So if there's an issue with most of the students, you want this to be in late hours, so we can do is like we can start this class by
you can do one
6:30.
thing मैम मैं क्या एक चीज बोल सकता हूँ मैम
Yeah, sure, sure. Huh.
मैम बात ऐसा है कि अगर जैसे 6 से शुरू होता है लेकिन मैं मेरा ज्वाइन करने तक मैम 6:25 या 6:30 बज जाता है मैम तो
Okay.
मैम ऐसा कर सकते हैं हम लोग थोड़ा एक्सटेंड भी तो कर सकते हैं लाइक 8:30 या लाइक 8:45 लाइक दिस
Definitely, definitely, we can do that. It's see, minimum I have to take 2 hours of class, but we can extend it. Even see, in every class, at by the end of the class, I'm like free. I ask you all to ask your doubts, any question that you want, any topic you want, because I'm there just to explain you the terms. I'm there just to teach you. So, what's the point in just spending the time here and getting no concepts with you? So I would love to do that. Any topic that you want to discuss, we will take that by the end of the class. And if I think if you join it by 6:25, 6:30 now, so no issue because I start the class by 6:15. I wait for 15 minutes to for all the students to come, and after that I start the class by 6:15 only. So there's no issue in extending the
yes
class. So I hope I'll see you all and wish you a very happy Holi.
happy Holi मैम
Okay, okay. So that's it from my side today, and hope to see you guys next week too. Take care
yes
and
मैम
a very happy Holi.
will do मैम
Okay, see ya.